Alright, so let's look at a word problem with cylinders. A Pearl Art Supply store sells paint solvent in a cylindrical can that has a diameter of 4 inches and a height of 6. The giant economy-sized can of the same solvent has a diameter twice as large and the height is the same but costs 3 times as much. Which is the better deal? So we want to see which ones hold more for a better price. So we're talking about the volume of the can. So the first one says it has a diameter of 4. So we want the radius of this. So if it has a diameter of 4, that means it has a radius of 2 because the radius is half, right? And then the height of it was 6. And then a giant economy size has a diameter of 8, right? I think. Let's go back and look. Yep, twice as large. So twice as large as 4 would be 8. So that means it has a radius of 4 and the height is the same. So we need to find, and we know this one costs this, and this one costs 3 times as much. We don't know how much it costs. So let's find the volume. The volume is pi r squared h. Okay, so let's find the volume of each of these to see which one holds more. Obviously, we know this one's going to hold more, but by how much more we don't know. So it's pi times 2 squared times 6, and this is pi times 4 squared times 6. And so this will be 24 times pi, and this will be 16 times 6 is 96 pi. And then when you solve that, you get 75.4 inches cubed here and 301.59 inches cubed. Now, if this price is 3 times as much as this, you want to see, okay, does this hold 3 times more? So what you do is you multiply this by 3, and you get 22.6. So this one actually holds more than 3 times as much. So the economy size can is the better deal. All right, and then we need to do the surface area. So how do I do the surface area? It's 2 pi r h plus 2 pi r squared. So plug everything in. So 2 times pi times 2 times 6 plus 2 times pi times 2 squared plus 4 times 2 is 8 pi. That's 12 times 2 is 24 pi. And you end up with 100.53 inches squared. And then we'll do the same thing on this one. So 2 times pi times 4 times 6 plus 2 times pi times 4 squared. And you end up with 251.32 inches squared. So obviously this one has a bigger surface area. All right. A cone is a right circular cone with a height and base radius, has a volume of 1/3 pi r squared h, and a surface area of pi r square root of r squared plus h squared. So again, write these down. A cone has a volume of 1/3 of the cylinder. So think of a cylinder. You've got one here, you've got one here, and you've got one there. So that means you have 3 cones in one cylinder. All right, so find the volume and surface area of a cone with a height of 12, All right, so your height is 12, your radius is 9. We want to find the volume. So volume equals 1/3 pi r squared times h. So 1/3 times 3.14 times 9 squared times 12. And that's 81 times 12. And so you should end up with, what do we end up with? 81 times 12 times 3.14 divided by 3. Should end up with 1,017.36 meters cubed. All right, surface area is pi r square root r squared plus h squared. So that's 3.14 times 9, and then 9 squared plus 12 squared. So always do what's underneath the radical first. So that's 81 plus 144. So it's going to be the square root of 225. All right. Which is 15. So then you end up with 3.14 times 9 times 15. And you get 423.9. 423.9. All right, and so that's how you're going to do the second one too. All right, so let's go to a word problem. Many northern states stockpile salt to use for melting road ice. In one state, the highway department builds sheds in the shape of a right circular cone to store the salt. Current sheds have a diameter of 30 feet and a height of 10 feet. Okay. The department plans to build a larger shed to hold more salt. The larger shed will either have a 10-foot longer diameter with the same height or the same diameter and a 10-foot greater height. Calculate the volume for each proposed shed. So let's look at the current shed. The diameter is 30. The height is 10. So you can either have one that has a diameter that is 10 larger, so that would be 40, with a height of 10, or you can have the same diameter, which is 30, and then increase the height 10 more. So those are our two options. So the first question asks us to calculate the volume for the proposed shed. And so that is, remember, that 1/3 pi r squared h. So r is 20 on this one, so 20 squared times your height is 10 times pi, and I'm going to divide it by 3. So 20 times 20 times 10 times 3.14 divided by 3. And you get 4,186.66. Okay, and then you do the same thing for this one. 1/3. The diameter is going to be 15 times 20. All right, 15 times 15 times 20 times 3.14 divided by 3. You get 4,712.39. So obviously the second one option will hold more. Okay, so now they want us to calculate the surface area. So surface area formula is pi r square root r squared plus h squared. So that would be pi times 15 times 15 squared plus 20 squared. And when you do that, you'll get 1,178.10. And if you guys calculate this one as well, you'll end up with 1,404.69. 0.96. Okay, so that's the surface area. And then the last one, which design seems more economical? Well, this one holds more. It's got the same diameter. So and it has a smaller surface area. So just increasing the height would be the better option, okay? All right, and the last thing we'll go over is a sphere. A sphere's formula, the volume is 4/3 pi r cubed, and the surface area is 4 pi r squared. And so how would you find the volume and the radius of a sphere? The volume and the surface area, this should say surface area of a sphere with a radius of 4 inches. So we would just do 4/3 pi 4 cubed. And you get 268.08 inches cubed. And then the surface area is 4 pi 4 squared. So that would be 201.06 inches squared. All right. Metrothelia is replacing existing spherical water tanks with larger spherical water tanks. The Water Commission insists that to provide for future expansion of the city, the new capacity of the tank should be at least 5 times the capacity of the old tanks. If the city purchases tanks that have a radius that is twice the radius of the old tanks, will these tanks satisfy the Water Commission? So we want the new tanks to be 5 times as much, right? Holds 5 times as much as the old tanks, okay? So the formula for volume of a sphere is 4/3 pi r cubed. All right. And it says that the radius for the new is twice as much as the radius for old. So we want to see if this will work. So what we do, if we put in twice the times of the radius, can we figure out if we'll get 5 times as much? So how would I simplify this? This is 2r cubed. That means 2r times 2r times 2r. So that would be 8r cubed. And then if we're going to multiply this by 4/3, this would be 8 times 4/3 pi r cubed, which is the original formula, right? So this is 8 times as much. So will this satisfy the Water Commission? Yes, because it will end up being 8 times as much rather than 5. And as long as it's at least 5, that's all that matters. All right, so the last of it, you have some worksheets that I have attached, so please make sure you complete those there for a grade. One's on prisms, I think, and the other one's on, I can't remember, cylinder cones, but just look on the attached assignments and look to see where you submit them and the worksheets that I've attached. Thanks.